So without further ado, we have Mr. Don Flaten. So Don Flaten is a professor in the Department of Soil Science at the University of Manitoba, where he specializes in crop nutrition, soil fertility, and nutrient management teaching and research, with a focus on agronomic and environmental points of view. Let's welcome Don Flaten.
Thanks, Caleb. Okay, good morning, everyone. Were any of you at the Ag Days social last night? Or maybe I shouldn't ask for a show of hands because the people who were there probably aren't here. This reminds me of my Friday morning lectures in the Faculty of Agriculture, where we've got a lot of student socials on Thursday night, and it's hard to get students into class on a Friday morning. Anyways, I'm going to talk about high-yielding cropping systems. Can you load my presentation in? Here we go. And some of you might wonder, what can a farm boy from Saskatchewan tell people from Manitoba about high-yielding cropping systems? Well, on our farm in southern Saskatchewan, we had autonomous tractor driving. Way back in the 1960s, my dad put me at 9 years of age onto a John Deere AR, and he could just walk away from the field, and it would be done by robotic control. And the operating costs were only 1 cent an acre. I earned 1 cent an acre for every acre that I did. So I've experienced with this advanced technology. How many of you were around in the 1980s when we had intensive cereal management being promoted and maximum economic yield? I was a Saskatchewan agriculture provincial soil specialist at the time, and we tried to show how all the parts of the crop production system were like a chain, and the limitation to the overall strength of that system would be the weakest link in the chain. Actually, that's not necessarily a bad idea. I took that idea a little further when 19 years ago I presented at Ag Days about how to make $300 an acre with canola at $5 a bushel, trying to encourage people to think in a more integrated fashion about their cropping systems. And what we had then was a system of taking every single input from every booth at Ag Days, and if you bought everything and you expected the yield increase that everybody told you about at their booth, you should be able to grow 100 bushels per acre canola like no problem at all and make lots of money. But of course, it doesn't work out that way. And in fact, this was proven in an on-farm study that a fella in Alberta did 15 years later. He put $300 worth of extra inputs in his canola field, and it yielded 1.5 bushels per acre. So he would need at least $200 a bushel for his canola in order to justify all those inputs. But really, this concept of the intensive cereal management, the maximum economic yield that we were wrestling with in the 1980s, still applies today, but it's a little bit different. We've increased our productivity, our yield potential is greater, and I like to use a little different term now. I like to talk about integrated crop management. So what I'm going to talk to you today about is just one component of the crop production system, but I want to stress how important it is to think in an integrated way about everything that we're doing. So I'm going to talk about soil fertility, nutrient management, and within that topic, I'm really just going to focus in on nitrogen and phosphorus. But I want to pay due respect to the overall system. If we take a look at crop yields over the last 40, 50 years since I started university as a student back in the 1970s, the average yield of wheat in Manitoba has more than doubled. In the 1970s, it was about 25 bushels an acre, and now we're up between 50 and 60 bushels per acre. That's made a big, big difference in the soil fertility programs that farmers have to work with. Higher crop yields naturally have higher N requirements, especially for crops that have high protein content like wheat and canola. So if we take a look at the sort of 4R nutrient stewardship concept about rate, source, placement, timing of nitrogen, and we look at rates of nitrogen fertilizer, they have to go up in order to sustain those higher yields. And farmers have responded with that. If you take a look at the application of fertilizer in Manitoba over the last 50 or so years, and thanks to John Hurd for putting this information together, you can see that the fertilizer nitrogen applied in red keeps pretty close track with the blue line, which is the amount of crop removal of nitrogen. There's not a huge amount of extra nitrogen being put on by farmers, and there's not a huge nitrogen deficit either. So we've got pretty good evidence that these higher yields are going to take higher end fertilization rates. That ends up with an economic cost, though, of about $500 million, $500 million a year that Manitoba farmers spend on nitrogen fertilizer. So it's a very, very important expenditure, very, very important agronomic input. And if we take a look at how to manage those potentially high yields, we have to sort of re-examine our nitrogen recommendations. And even though I might not know very much about high-yielding crop production systems, because I'm from Saskatchewan, I do know some people who are really good agronomists. And one of those really good agronomists is Amy Monger, who's completing her PhD in plant science as we speak. And we had some plots near David Lawden's home base on his farm, and they were the highest. It was the highest yielding site we worked with in our high yielding wheat study, and we were able to get up to 129 bushels per acre of hard red spring wheat with Prosper as a variety. But that took 200 pounds of additional N on top of the soil test N that was in the soil in the spring. So in order to hit those high yields, you're going to have to pour on the nitrogen. So in that particular study that Amy was leading, we had a number of sites across Manitoba. And I'm reporting the data here for all the sites except for Carmen, 2016, where we had hail damage the crop, sort of set those results aside. This is the soil test level that was in the field in the spring. This is the optimum rate of nitrogen fertilizer that was applied, the optimum yield at that rate of fertilizer, and the amount of nitrogen it took, soil plus fertilizer, to hit that optimum yield. And this is just using simple arithmetic and looking at what point did we no longer get a significant increase in yield or profitability. And we were averaging around 2 pounds of N per bushel at that optimum rate of N for hard red spring wheat. And that's an important point. Older varieties of wheat were like 2.5 pounds of N, maybe even 3 pounds of N per bushel at their optimum yield. We're down to 2 pounds of N per bushel for that economic optimum. So our new varieties are more efficient, but they're still much higher yielding. We have to consider that. One of the side effects of this really high yield potential is the protein content at those optimum economic yields are not that high. Here's a list of the protein contents for Brandon wheat, which is a lower yielding wheat but higher protein, and Prosper wheat. On average, when we take a look at the protein content at the optimum economic yield, 13% for Brandon and less than 12% for Prosper. So in order to get Prosper up to 13 or 14% protein, you're going to have to go beyond the economic optimum rate of N, according to the data that we worked with on prices, a couple of years ago. Anyway, so it's not always a sure thing to go for these high yields if you can't get the high quality to go with it. Now, if you've got a situation where you've got very high yielding wheat and you want to hit that milling quality wheat, one option to consider is post-flowering applications of solution nitrogen. Anybody here do foliar fertilization with urea, ammonium nitrate 2800 cut 50-50 with water? Anyways, this can increase protein content. It doesn't increase yield. If we take a look at these data on yield, adding 30 pounds of nitrogen as a foliar after the crop is flowered doesn't increase the yield. If we'd added that 30 pounds at planting, we'd get an increase in yield, but it's really too late for increasing yield. But if we take a look at protein content, the protein content boost from that 30 pounds post-anthesis was about 2%. So a very substantial increase in protein content with that post-anthesis nitrogen. And that's another technique then that you can use if you're concerned about a high yield of wheat that might have low protein content. There's an option to apply foliar nitrogen to give it a little extra protein boost. But if we're looking at the right rate and we want to figure out exactly what the rate of nitrogen is, we need a nitrogen response curve that we can define mathematically, and then we can convert it into a revenue curve, and then we know our nitrogen costs, and then the economists can calculate, well, exactly where do we find that maximum profit. But you need this information about exactly what that curve looks like, and that's a very tricky issue. So what we see if we go into the literature, this is some corn yield response in Iowa. And in these trials, you had some very consistent responses to nitrogen, corn yield increasing in this particular case, then leveling off. But these data could be represented as a different sort of response. It could be sort of a curvilinear response and then leveling off. It could be what we call a quadratic equation, where it sort of continues on and then it goes over a maximum and it starts to tail off. Or it could continue to increase a little bit. All of these different response curves have substantially different optimum rates of nitrogen economically. If you take these types of response curves, each one of them, and then calculate exactly what the economic optimum rate of fertilizer is, if you take the one with the two straight lines, it comes out to 95 pounds an acre of nitrogen, gives you your optimum yield. If you take this quadratic plus plateau here, it's 150 pounds of N. The quadratic equation, 200 pounds of N is the optimum. And if you use this model here, you're going to calculate the optimum rate at 260 pounds of N. So you've got almost a threefold difference in optimum economic rate of nitrogen, just depending on how you define that response curve. So I don't get very enthusiastic about using these response curves, because as soon as you pick your response curve, you're really picking whether you're going to be optimistic, pessimistic, or right on about the fertilizer rate. And if we take a look at, in this particular study, which response curve was the most accurate, they found that it was this one here, where it's curvy up to this point, and then it stops and levels off. At 160 bushels per acre, the optimum rate was 150 pounds an acre. That's about 1 pound of N for every bushel of corn. Pretty good rule of thumb. What about wheat? We did the same analysis as those guys did, but with Amy Monget's data set on all these different site years, and we worked with the different varieties, Brandon and Prosper, and which one of these response curves was the best statistical fit? Well, it varied with the variety, and it varied by site, and there was not a single case where we got the quadratic plateau model, which was recommended in that previous paper as the best model. It didn't work out to be the best model in any of our site years. So we don't have a really accurate way to predict yield response to nitrogen fertilizer that's consistent across site years and varieties. So what we did in our study, we just said, okay, we're just going to go with the arithmetic. Where do we make the most profit? This is one of the reasons why we see some contradictory recommendations. If you take a look at the recommendations for nitrogen fertilizer in corn, in the old corn production guide, there was a recommendation, probably typically getting pretty close to 2 pounds of N per bushel with some of the older hybrids under more restricted yield potential here in Manitoba. And then if you take a look at the soil fertility guide, it was still about 1 3/4 pounds of N per bushel. And AgVise Labs is recommending less than that, 1.2 pounds of N per bushel. And North Dakota, which has completed some field trials recently, down to 1.15 pounds of N per bushel. These recommendations here for much lower amounts of N per bushel compared to some of our traditional recommendations in Manitoba. And part of this is genetic improvement. The new varieties, the new hybrids of corn have higher yield potential. Corn doesn't need high protein content. It's just an energy source, and so you can get some fantastic genetic yield increases without necessarily a whole bunch more fertilizer nitrogen. If we take a look at some of John's data, and John, you might be showing some of this next just to reinforce this, but he had trials across these various locations, and he was measuring the response to nitrogen fertilizer, and I've got those data points here with the yield on the y-axis and the nitrogen rate, including the fertilizer as well as the soil background nitrogen. And when he ran his data through with a quadratic response formula, it was one of those nitrogen response curves, he found that for the lower yielding sites, the optimum rate of soil plus fertilizer N was 160 pounds of N or 185 pounds of N for the higher yielding sites. And the average optimum response, though, when we do the calculations just old-fashioned Stone Age way, looking at each trial and where did we get the maximum profitability, we found that the average across all these sites was only 139 pounds of total nitrogen per acre. So when we do things the old-fashioned, old-school, just arithmetic, Stone Age way, we get a lower number. And in fact, if you take a look at these data and you look at where the arithmetic, just using the arithmetic, where did we find the optimum yield and optimum nitrogen rates? For the lower yielding sites, there was always less than what was predicted by this yield response curves. And in the high yielding sites, 5 out of the 7 sites had optimum N rates less than what was predicted by averaging through that mathematical curve. So we've got to be very careful. What curve are we using to predict our yield response to nitrogen? Because it can have a big impact on the amount of nitrogen that's recommended. If we take a look at the average amount of N per bushel in these data for the optimum yield, it came out to less than 1 pound of N per bushel. Very, very high yielding corn response to nitrogen. Part of the reason for this very small number here, less than a pound of N per bushel of corn, is that we're getting a lot of nitrogen from the soil. You don't need as much fertilizer if the soil is kicking out lots of nitrogen on its own. So one of the things that's interesting about this experiment is that when we estimated the amount of nitrogen mineralized from the breakdown of soil organic matter, from the decomposition of humus in the soil, we find these numbers are just staggering. In some cases, well over 150 pounds of nitrogen coming out of the soil during the growing season from the breakdown of organic matter. And this is an especially important factor in row crop systems. And I'll show you a diagram that illustrates that. Marla will be speaking later this morning, so will John. But a couple of years ago, they buried underwear, cotton underwear, in some fields. And if you take a look at how fast the decomposition was for this type of organic matter, the row crop corn underwear was completely decomposed, like within a couple months of being put in the soil. It's warm, it's moist. In Saskatchewan, we'd call those strips in between those 36 rows, we call those summer follow strips. Lots of moisture, warm temperatures, lots of decomposition. Perennial forage underwear, you could probably wash it up and wear it. I don't know if you did that. John, did you salvage that underwear? You changed it. Yes, okay. Yeah. Anyways, there's a lot of decomposition of organic matter in row crop systems. Thank goodness in our corn production system we're also adding a lot of organic matter back at the end of the growing season. So if we take a look at the optimum N rate for our wheat trial, high yielding wheat trial, we also found a lot of mineralization. So here's the estimated nitrogen mineralization during the growing season, and it varies a lot. Even on the same sort of region here, we've got Brunkild in 2016, the lowest amount of mineralization during the year. This is on Dave Lauden's farm, 35 pounds of N. And at Carberry in the same year, 130 pounds of N being released from the breakdown of soil organic matter. Very, very large amounts of nitrogen, but highly variable from field to field, even in the same year. So one of the things that Amy did is she wanted to see if she could predict the breakdown of that organic matter and the release of nitrogen. And one of the things that you often hear about, if you multiply your soil organic matter by a certain factor, you can predict the amount of nitrogen that's released to your crop. Well, we looked at the stats for that. There's nothing. It's not a very useful predictor. Very, very useless. Here's the spring residual nitrogen. If you look at your nitrogen in the spring at 24-inch depth, maybe that reflects how much nitrogen can be generated from the breakdown of the organic matter. Not a very strong relationship there either, but a little bit better. Then we looked at Les Henry's indoor incubation test, where you let the nitrogen come out of the soil sample just by storing it for a month in your home, and then you get it analyzed a month after you've taken the sample. Not very useful in this study. Showed lots of promising results when we were doing growth chamber experiments. As soon as we move out into the field, though, it didn't work very well. And here's another soil analysis, a sodium bicarbonate extraction analysis. Showed really good potential when we were doing growth chamber studies. Take it out to the field with variable moisture and temperature. You can't predict the release of nitrogen very well. This is an environmental response. It's a biological process. And depending on what's happening in that field in that year, you could get very different results from that same field in a different year. So if we take a look at, we've got the Solvita test here. This is just another test that doesn't work for predicting nitrogen mineralization. So what about something besides rate? What if we look at placement source, timing sort of combinations? One of the things that I'm quite concerned about going into the spring of 2020 is a lot of people did not get nitrogen fertilizer in the fall that would normally put on nitrogen in the fall, and they're going to be putting on nitrogen in the spring. And one of the things that hasn't been stressed maybe as strongly as we should is that if you don't have at least 2 inches of separation between your seed and the fertilizer, there's a high risk that you can have seedling damage. Here's Cindy Grant's work from just north of Brandon here with the Agriculture Canada Research Station. And when she was working with either 2800 UAN solution or 4600 granular urea, the more nitrogen she put on 1 inch beside and below the seed, the less the stand count for canola. Now, she got a benefit from putting on agrotane, which is an inhibitor that blocks the hydrolysis of urea and makes it less toxic. But UAN 2800 or urea 4600 applied at rates higher than about 40 pounds an acre, if it's only 1 inch away, can still damage your stand. So what about other options? You can broadcast nitrogen fertilizer during the growing season if you can't get it on at planting. And here's some data from Cindy and Ramona's work at Brandon here again. And if we take a look at these data, the broadcast fertilizer in the form of 4600, pretty high ammonia losses within that 4-week period. You can reduce them or certainly slow them down by using something called Super U. It has an inhibitor in it, but it only really slows things down for like a week or 2 weeks, and you need rainfall in that period to get that nitrogen safe and under the soil surface. But it's also interesting to note that if you can band that fertilizer under the soil surface, your volatilization losses are minimal. Also, if you use urea ammonium nitrate 2800 dribble, there's also some pretty low ammonia losses. So we've got options with these different fertilizers now, different additives, and we don't necessarily have to have everything on in the fall to succeed with our nitrogen fertilizer program. Amy Monger's high-yielding wheat project also evaluated mid-season applications if we put on all the nitrogen at planting, and then we had other treatments where we put on some of the nitrogen at stem elongation or flag leaf. We had excellent yields from the mid-season applications, and in fact, in the case of stem elongation, we actually had an increase in yield over putting it all on at planting. We had 2 sets of sites. The gold sites are the sites that Amy Monger managed herself, silver sites where we had collaborators, but similar data. You can split your nitrogen up. If you can't get enough nitrogen on at planting, there's still options to put it on in mid-season. Keeping in mind that in the years that we were working, 2016 and 17, we had decent rain showers shortly after applying the nitrogen fertilizer to wash that nitrogen into the root zone. So what about the implications for phosphorus? Phosphorus is another important nutrient, and with the doubling of yields in the last 40, 50 years, we've also got a doubling of phosphorus removal. And so how are we doing on phosphorus management? If we take a look at phosphorus application rates, they've gone up during this period as well, and over the last 5 years, a particularly sharp rise in phosphorus application in Manitoba. How does it match up with crop removal? It's about even. Very little difference between phosphorus application rates and crop removal rates. It's another important economic factor, $200 million a year invested in phosphate fertilizer. If we don't put on that phosphate, here's what happens. Martin Entz, who's leading some very good work in organic cropping systems, has been very concerned about mineral nutrition, making sure that organic farming systems have access to some way of restoring their phosphorus fertility. After 15 years, his organic system collapsed where he had no additional phosphorus, where he put on just a little bit of beef cattle manure, get that phosphorus status back. It's actually very productive again. Long-term trials near Indian Head, Saskatchewan, from 1960 to 1990 with green manures First 15 years, the green manures were doing a really good job. But after 15 years, we ended up in a situation where the yields were declining with the green manure and going up with the fertilized plots because green manures weren't adding anything except for nitrogen. And you might think, well, this is pretty obvious. Everybody knows that. Something published just this week in Nature, the world's leading research journal. And somebody has just published a paper on Monday saying, look out, this zero-budget natural farming system where no inputs has a threat in terms of productivity because it only brings nitrogen into the system. This type of farming system could limit the supply of other nutrients. And I'm going like, duh? But anyways, it's published in Nature. It's a very prestigious publication, but it seems obvious to most of us. So if we take a look at phosphorus fertility, you need to maintain background fertility that's also complemented by in-row applications of starter fertilizer. Experiment in Saskatchewan. If you had low background fertility, applying the seed row phosphorus couldn't match the yield of having decent background fertility as well. This work was published about 35 years ago, but Adam Gurr, who farms near Brandon here, has been doing some similar work and getting similar results through his AgriTruth research group. 30 bushel increase to supplemental background P over and above seed row place starter P. Big responses here in his trials. So when it comes to phosphate fertilizer rates, you can be fertilizing for the short term or the long term. Short term, you've got rental land or you're retiring soon, an old guy like me maybe. You don't necessarily need to put much more than some starter P on, but if you want long-term sustainability, you need to build your P up to a certain level and maintain it, and that means that you're going to have to watch your rates of removal much more closely. So the Soil Fertility Guide recommendations in their old form from our 2007 version have very low rates of application. If you had 10 part per million soil test P, it's recommending only like maybe 30, 20, 10 pounds for wheat and canola and soybeans respectively. Very low rates compared to removal. If you stayed within those rates, especially for the seed row placed P, which is very restricted, you end up with a challenge in terms of phosphorus balance. So some people say, well, why don't we just put on more seed row P? Well, you can very quickly end up with seedling damage from the phosphate fertilizer too. This just shows that rates above 20 pounds an acre, your yield can fall. And indeed, here's a trial from Portage La Prairie a couple of years ago, and where they put on even 20 pounds of phosphate in 12-inch row spacings, the yield and the plant stand were compromised. So when we're talking about the average yields for various crops in Manitoba and the average rates of crop removal relative to P application, we've got these deficits, and farmers have that challenge to try and figure out a way to restore that deficit. So what sort of things can do, or what can farmers do? Apply sufficient P side-banded so it doesn't cause you seedling toxicity. Use a rotational fertilizer strategy where you might add extra P to your cereal crops. You might periodically band P in the soil during the fall with your tillage. Some people putting air kits on a heavy-duty cultivator, for example. Building your P to a target level with manure is an excellent option if you have access to it. But it's all really important to integrate across different systems. So just to summarize, with respect to nitrogen rates, modern varieties, higher yield potential, we need high protein in our spring wheat for milling quality, so we've got to apply more nitrogen fertilizer. The optimal economic rate varies a lot with the amount of soil test residual N, but also yield response curves and the amount of N that mineralizes during the growing season. These are not easy to measure. Source timing and placement. Don't put too much nitrogen with your seed, or within 1 inch of the seed row. It's too dangerous for the crop stand. But we've got new sources, new additives. We've got dribble banded UAN options, all sorts of other options that we can consider to complement seed placed N or fall banded N. With respect to the protein content issue, there's also an option for post-anthesis, post-flowering foliar application. Rate management and phosphorus, there's the two strategies. You have to decide what's good for you. Rates of phosphorus eventually must match up with rates of removal, otherwise your productivity will decline. And the combination of P fertilizer and P fertility is best for crop nutrition. Placement and timing, watch how much P you put in the seed row. There are salt-sensitive crops like canola or peas or soybeans that we need to be careful with, especially if the spring is dry. So looking back at this concept of integrated crop management, I've just talked about nitrogen and phosphorus. Everything else is really important in this list. And so I don't want to depreciate the importance of some of the other speakers this morning. And I want to quote Earl Johnson, who wrote this out in a presentation the year that I was born. Maximum input of fertilizer, tillage, and everything else gives maximum yields, but they're not necessarily the most profitable. You need an ideal combination, and that combination is an integrated farming system that is very important for you folks to work on, not just with that single-minded focus like I have with respect to soil fertility. So, thank you very much for your attention this morning, and I'll turn the floor over to the next speaker.
Before you run away there, Don, got a little gift for you. Yeah, on behalf of Manitoba Ag Days and FCC, I got a little gift for you. One more round of applause for Don Flaten.